Good morning, everyone, and thank you for attending our Discover MapInfo webinar. My name is Loki Kronier. I'll be your host, and today I'll be demonstrating just some of the tools in Discover that can be utilized within the environmental sector. First of all, what is Datamine Discover? We acquired MapInfo Discover last year, July, and for those who are not familiar with the software, it is a GIS specifically developed for the natural resources industry. It has everything you would expect from a GIS. It's very projection savvy, capable of managing large data sets. But today, like I said, I want to focus on a few features that is applicable within the environmental sector. This is a quick outline. We are going to look at the gridding functionality, how to create raster grids. I'll demonstrate some other raster operations such as volume calculations. Then we're going to extract some drainage features from a topography using the hydro analysis tool, analyze some multi-banded Landsat imagery, look at the drill hole module, and lastly compute area changes and create maps. Now, the raster module in Discover provides a rich suite of functions and tools for creating and analyzing gridded rasters. It's been designed to integrate with a number of different formats, everything from geochem surveys, such as shown over here, or geophysical grids, or LiDAR data. So let's get right to it. The first thing all the users will notice is the migration to a ribbon-based layout at the top. And what I have currently loaded in here is a point grid, each point representing X and a Y and an elevation. And I want to grid this based on the elevation. So I'll go to the raster ribbon, click on create raster. We have a number of interpolation methods. I want to choose triangulation for this exercise. We're going to choose dotted spot. The column will be AHDRL, which is our elevation. The rest I'll leave as default. And the cell size I'm going to make 50. And there we have it. I'm going to switch off the points and zoom out a bit. And there we have a digital elevation model. Now we can manipulate the colors the way we want to. If you click on the raster, layer tools option pops up over here. We can click on advanced color. And there are a number of weird and wonderful color schemes available here. For now, I'm just going to stick to the normal pseudo color. A handy addition to Discover is access to Bing satellite imagery, and this is useful to check whether one is correctly georeferenced and if the raster grid is aligning with the aerial imagery. So if I lower the transparency of this grid, and we zoom in a bit, you'll see that it aligns up quite nicely. Okay, now within our raster ribbon, we have a number of functions. I obviously won't have time to go through all of them, but the tool I want to show you is how to create contour lines quickly. So we choose contour, we choose our dotted spot grid. We're going to use fixed intervals, and let's round the interval off to the nearest 10. We'll use the spacing of 10. And if I switch off the raster, there you have your contours, which you can now label and color any way you like. The next tool I'd like to show is the volumetric analysis between two rasters. And I thought this would be quite handy in the environmental realm of things. to calculate volumes of pits, etc. So what I have loaded here is a pit contours. Just want to switch this off. And I've clipped our raster using this mining lease area to only have the part that we're interested in. Now this pit design is in vector format, as you can see, each shell representing a different elevation. So what we want to do is rasterize the pit design, then combine it or merge it with the topography, and then calculate the volume of earth that was removed. First of all, we're going to rasterize it, so I'll go back to raster operations, choose the option. We're going to choose pit contours. I want the average cell assignment. I'm going to make the cell size 20, and we process that. And if I switch off the vector layer, there we have our rasterized pit contours. Next step would be to merge it with the topography. Raster operations merge. We select the two, Datamine before and pit contours rasterized. And make sure Datamine before is our primary grid. Resampling method by cubic, and we're going to call this Datamine after. And there we have it. Now that we have both before and after topography, we are going to go back to operations and choose the volume utility. Datamine before will be our input. The volume method will be between rasters. Secondary grid Datamine after, and the volume action will be below the primary raster. If you were, for instance, working with dumps, it would be above. And we process that. And there we have our volume, which is currently in meters, but you can choose a number of different units, whatever you would like to work in. Okay, so there's still a number of tools. Next up, what I'd like to show you is our hydro analysis tool. This tool enables one to create streams and catchment areas from an elevation raster. It calculates the flow direction using the slope of the topography. And then another thing I'd like to show you is view shed analysis, which is line of sight studies, quite important within the environmental sector. I'm going to use the same topography I did for this exercise. First thing you'll notice is the polygon digitized in the middle. You'll notice when you look at the raster that it's rather flat, and this will influence our the creation of catchment areas and stream network, as it serves as a data into flow. So we're going to navigate to the analysis ribbon. There's a wealth of statistical tools here to do correlation matrices or geophysical filters. We're interested in a hydrology tool. We select Dalit spot, elevation unit in meters, and under pitfall options, this is where we specify the polygon exclusion mask, which, as I explained, is the lake within the middle of the raster that will serve and interfere with the creation of the streams. The minimum catchment area is the level of detail you'd like. I'm going to put that to 10, and the rest I'm leaving as default. This will take a while to process, and while that's processing, I would like to show you a video with some of our newer features within Discover. Now, in our latest release, there's been big improvements on the use of GPS data. What is currently shown on screen is the import of a log file with a bunch of points and tracks that were mapped. One can also make use of this waypoint navigation, and with Discover being compatible on a mobile tablet, one can use the onboard GPS of the tablet, and this really streamlines the process of data capture. You can also import and export GPX files if you would still like to work with your own external GPS. Now this function is just goes to show that the software is compatible on map, and you can do your digitizing and capture on the tablet itself. You don't have to type it. You can also create pick lists and drop down menus. And this last feature is what's called geotagged images. These points refer to where the image was taken, and then you can view the image on the right and also enter data in for it. I thought this could be quite handy in the environmental world. Say if you were rehabilitating different sites and would like to keep track of the progress. And it also shows in what direction the photo was taken. And this data is usually available on most smartphone photos. So I think our tool would be finished running right now. It's done. So what we have here, I'll just lower the transparency of this. The outputs from our analysis include these blue lines, which represent the streams. We have these points that show the source as well as the outlet of each stream. And then these big polygons refer to the catchment areas. Now, say you wanted to add a thematic legend to the area size of each catchment. It's as easy as going to the map ribbon, clicking on add theme. There's a number of options over here. Individual values, dot density. We're interested in ranges, and I'm just going to take region ranges. Take the default one. We're going to choose the table for our watershed and our watershed area field. And let's add another 3 ranges or so. And click OK. And there we have our ranges. Now, if I click on our thematic legend and I go to style, we can change the theme or the field, the method used, or the color palette. So very quick and easy to perform. Now, the last thing I want to show you on this specific raster is the use of viewshed analysis. Let's switch off the theme for now and increase the transparency of our elevation model. Let's say, for instance, we have a proposed site on this hill over here. I'm going to draw a polygon that will represent the site. And for instance, let's say we have a town situated down here next to the lake, and we want to see whether or not this, let's call it a silo that's going to be built here, is visible from the town's perspective. We go to the raster menu and we click on interactive line of sight. Then we draw from where the viewshed is up until our site. And this profile over here represents a cross section. The green is what is visible and the red is non-visible. Now, if I make my cursor visible on the map, let's make it a star, and I choose my elevation model and I hover over the area here, it gives you the distance from the viewpoint as well as a value, which is in this case an elevation. And as we go closer to our viewpoint, you see the star moving on the right. The green, remember, is visible and the red not. And you can see in this case that our site is in fact not visible. So this is also very useful, and you can change the view areas as you like. Okay. Next, also quite important, is the analysis of Landsat imagery. This is quite important in the environmental sector for monitoring vegetation health, It's also been used to predict and control wildfires or study impact of droughts. And this imagery is freely available on the USGS website. So if we go back to the software, what I currently have loaded in here is what is called a multi-banded raster. So I used the options shown here, create raster multifile, and I combined a series of 10 Landsat images and overlaid them. Now there's a number of viewing options within Discover. One can either view it as pseudo color, in which case it shows one band at a time, or one in what's usually more important is the use of RGB. I can apply different color stretches. I'm going to use a histogram color stretch. And you can manually assign each band to a spectral unit. Discover comes with preset templates. This is specifically Landsat 8 imagery. And if I hover over these, it highlights certain spectral properties. And this is good for temporal analysis if you want to study what has happened over the years in a certain area. If I, for instance, click on this healthy vegetation, you can see that the vegetation is highlighted as a yellowish color. If we will, for instance, choose the infrared, the plant absorbs the red light and healthy vegetation is shown as red. Okay, so let's move on. I'm not sure how many of our attendees work with drill hole data, but Discover comes with a comprehensive environment for managing, processing, and visualizing drill hole databases. We're going to generate some cross sections, digitize the interpretation, and visualize and model it in 3D. So what I've loaded here is a surface map, a topography underneath it, and these dots represent the colors for our drill holes. You can put their labels on. Now let's say, for instance, we want to have a cross section across this line. We're going to navigate to our drill hole tab. We're going to say generate sections. It's going to use a selected line. And you'll see the red indicating the envelope width. This is now for a section. We can also do a plan or a long section. We're just for now going to leave everything as default. You can create offsets and annotate the downhole data differently, but for now I'm leaving everything as default, and I'm going to generate a section. And here we have our downhole display showing the depth, and the colors used here is the geological map intersection, so that's also quite handy. Now let's display our downhole data. We're going to go to this tab over here. First of all, I want to display the lithology that was logged downhole as a trace shade. So I'm going to click on trace shade over here, choose my lithology table, click on geo code. I already created a legend for it, and choose a section I want to apply it on. There we go. Let's say we also did a assay downhole, and I want to display our results as a bar graph next to it. Click on bar graph, choose the assays, create a maximum display width. I also have a legend for this one, and I want to offset of about 5 mil to the right. We apply that, and there we can see our assay data also shown towards the right. Now let's say, for instance, that this yellow unit over here is where we encountered the water table or whatever the case is. we can add what's called a section layer to our cross section. We're going to go to our section manager. Now there's also lots of other tools that I won't be able to show, like compositing our holes, our beta measurements in. Okay, here's our section manager. This one at the bottom is currently active. I'm going to right click and say add section layer, and let's call this water table, and it'll pop up over here. I'm going to make it editable and start digitizing a polygon. Enable my snapping, so we make sure it's accurately on the contact, and then we start drawing. And a nice addition is the use of this auto node function, in which we can just draw and we don't have to click every time. There we go. We can add a pattern to that just for display purposes. And let's just save that. Now let's say we want to view our drill hole traces in 3D. On the drill holes, there's this Discover 3D bar here, and let's choose our drill hole traces. We'll just select all of them, and underneath here it will now open up a new Discover 3D window displaying our drill hole traces. While that loads, I want to apologies for that. It's to be taking a while. We can carry on. Let me just give that a while to load. Now the last function I'd like to show you guys is this compute area change utility. This provides an efficient method to quantify and map changes in an area between successive layers of data. What we're going to do is compute the area change, generate the report, and create professional looking maps. Now let's say in this instance I have two polygons loaded, 2017 and 2018, and we want to map the changes that took place over time. In this instance, it represents a plant habitat, and we're going to go to the query button over here and select area change. Select 2017 and 2018. Now you can export this to a text file or CSV. I want to show the changes in a new color and a new pattern. Click OK. It gives us a map that indicate the changes. Just draw that in the correct map window. Red indicating areas added and blue indicated areas lost. And then we also have this report that shows us what type of habitat each is, what change took place, the percentage of change, the area, and a whole bunch of metadata along with that. I'd just like to see if our 3D utility. Now, let's say, for instance, we want to draft this map and create a layout for it. There's a number of ways in which we can do it. The one that I'm quite fond of is the scaled output under the Discover ribbon. We're going to choose scaled output. Let's say we want an A4 landscape at a 1 to 50,000 scale. Preview that. Now you can move the preview as you'd like. Let's Let's move it a bit to the corner. And if you're happy with it, we say accept parameters. Now it works like a wizard. The next step is to specify the details for your grid. Let's say I want a dot dash line rather, then dots, spacing of 2.5K, that's fine. And the next step is your title block. So we'll call this area change. And the office will be Johannesburg. Let's say plan drawing. You can specify details on your scale bar. Let's just leave it as default for now. And now it creates a new layout window. There we have our map with the grid. It's going to move it a bit to the side. Make some space for our title block here in the corner. And like every map, we would need a legend. So if I navigate to our layout window here and I click on the map, the legend will know what is loaded currently. We want a legend for those 3 frames. Change map, we're going to call added or lost. We're going to use unique values in added or lost column and style it with the same column. 2018 legend will be the habitat type, and 2017 the same. There we have our legend. Now let's say, for instance, we wanted to add this table over here. The first 4 columns we want to add in our layout. We can go back to our layout and say browser. It will show the open browsers. There's only one open currently. We select it. Let's just resize this a bit. Drag that down here. So it's very customizable and intuitive. You can add your north arrows and so forth as you go along. It seems like our time has come to an end. Thank you guys so much for attending today. If there's any questions, you can mail it to the site shown on screen. There's a few things to look forward to. Later this year, we will be releasing a mobile app that goes along with Discover that you can link up to the cloud, and this will really streamline the process of data capturing. And thank you guys again for attending. We hope to hear from you soon.